Okay, we're trying to do video number 4. I'm having a really hard time downloading these. Hopefully the quality may be a little less, but hopefully it will download a little quicker. Okay, we're moving to using all the things we've already talked about and trying to do it in a problem with grams. We're taking the stoichiometric concepts that we've learned and we're going to use that. So the other day when I was doing it with Holland, there was a way we did it that she felt like explained it well, so I'm going to show that to all of you. Okay, so we are going to start with problem number, with on your own 8.7. So turn to page 205. And the problem says one type of rocket engine uses the following reaction to develop its thrust. 7H2O2 plus N2H4 produces 2HNO3 plus 8H2O. Okay? So what we're going to do, the key is going to be that well, let me read the rest of the problem. If a rocket engine has 1,120 kilograms of N2H4 in it, what is the minimum mass of H2O2 necessary to allow the N2H4 to react completely? So let's ignore all of the things in there we don't need and see if we can figure it out. Okay. Mr. Keith is laughing at me. I'm not sure I'm doing funny. Okay, so let's look at the information we do have. We have that we have 1,120 kilograms of N2H4. Okay, so we're going to take that and just write that on our problem ahead. And already you should see something that is not going to work. Can you figure out what it is? We can't do moles in kilograms, so we're going to have to switch that to grams. So we know that we'll be doing that in a minute. Okay, and then the problem says, what's the minimum mass of H2O2? So this is the thing that we want to find out. Okay, and so the process I was telling Holland the other day is the idea that's going to help you and help you to not be confused. Okay, so we're going to change this to grams. We're going to come down and change this to moles, which is what we know through stoichiometry that we can compare. We can compare N2H4 and H2O2 in moles only. Okay, so we are going to go from grams to moles, then we can relate the moles of N2H4 over to H2O2, and then we'll go back up to grams. Okay, so that's going to be the process in all of these problems that you're going to do. And if you even need to draw this out, it's going to help you to think through it. Okay, so let's start off. The very first thing is we cannot leave this in kilograms. And this should be something that y'all have done so many times to be should be super easy. And so 1,120 kilograms. And actually, yeah, make sure I'm writing that right. Okay, over 1 times, think about what your conversion factor is. 1,000 grams equals 1 kilogram. Okay, we have 3 significant figures, so our answer must have that also. And so your answer is going to be 1.12 times 10 to the 6th grams. Okay, so that is now what's going to go up here. Okay, so I've changed that to grams. So now I'm going to be able to use that. Okay, so what's the next thing that we have to do? Think to yourself, what would you answer if I was asking in class? What would be the next thing that you have to do? Okay, well, we want to take it, to be able to relate these two things, we have to get it down to moles. So how do we do that? How do we get it down into moles? Well, we know that based on the atomic weight, okay, we can figure up 1 mole equals the weight of this. Okay, so you've got to find the mass of N2H4. Okay, oops, why I did that, I don't know. N2H4. Okay, so using your periodic table, you can look at it and figure up that we have 2 times the mass of nitrogen, which is 14.0, plus 4 times the mass of hydrogen, which is 1.01, and you're going to end up with 32.0 ammus. Okay, and remember when we take that, what that tells us is that 1 mole of N2H4 equals 32.0 grams of N2H4. Okay, so now we have our conversion factor. Okay, so by doing that, now that we know that, we're going to take how much we have of N2H4. We have 1.12 times 10 to the 6th grams of N2H4 over 1. I'm not going to write that just because I have so little space here. Okay? Times our conversion factor. Okay, we're trying to change this to moles so that we'll be able to relate them over 32.0 grams. Okay, when I multiply this all out, my answer is going to be, now again, look at your number of significant figures. We have 3. We have 3 here and 3 here. So we're going to have 3.50 times 10 to the 4th mole of N2H4. Okay, so we're going through this. We have gone from this process of grams down to the number of moles of N2H4. What is your next step? Okay, I want you to be able to think through this so you know what to do no matter how this is worded. Okay, now that you have it in moles, you can make the connection over to H2O2. You couldn't make the connection up here, but you can down here. Okay, so now how are we going to relate N2H4 to H2O2? This is where your balanced equation comes into effect. Okay, so what's our conversion factor going to be? How many moles of H2O2 are equal to how many moles of N2H4? Okay, so we have 7 moles, I'm writing all over this board, of H2O2 equal 1 mole of N2H4. Okay, so that's what we're going to do now is we're trying to make the relation between the two in moles. Okay, so we have 3.50 times 10 to the 4th mole of N2H4. Okay, I'm going to use my conversion factor. This right here. This is what because I'm trying to change to H2O2. 7 moles of H2O2 over 1 mole of N2H4. Okay, and once you multiply that out, see these will cancel out. Okay, once you multiply that out, you're going to have 2.45 times 10 to the 5th moles H2O2. We'll have to erase some things. Okay, so now in our process, we've done this to this.